Welcome to the UGC EPG Partitioning lecture series in computer science. In this series of lectures, we have been looking at the paper software engineering. So, this session will be a continuation of testing, but then I will be talking more on the various types of testing associated. Primarily, testing is being carried out at two different levels. One is called the black box testing and other one is the white box testing. If you look at black box testing, without trying to understand what are the internal components or the code, or by just understanding on the requirement, I may be able to write a test case. So, that is the preliminary objective of a black box testing. Some of the learning objectives of this particular session include, as you might know, the intention of testing is to carry out or execute a program with the intent of finding an error. So, the first three objectives are common as we have discussed for the testing, but then here this particular session we will be studying about the various internal types of black box testing and its mode of operation. So, why should we do a testing basically? Why should we do black box testing? So, in many cases you cannot expect a person to be perfect all the times. So, it is mandatory that we come across design errors, code errors at various point in time. So, with this as an intention, testing has come forth, and the goal of testing is to give some code, uncover as many errors as possible. So, given a specific code, you may have to find out as many number of errors as possible, but then the intention of black box testing is not so. So, black box testing, without looking at the code, if you are able to arrive at some test cases. So, if you can go back and look at the sessions 1 and 2, where I would have told you about a problem wherein we said write a code to find a number between 0, 100. So, what does this value of between indicate? So, it is 1 to 99 or 0 to 100 is the understanding which we thought we will have. So, just by looking at the program, if I am able to arrive at few test cases, so that is supposed to be the black box testing. Whereas, after writing a piece of code for the same program, if you are about to check on the code whether it is been executing properly, then it becomes white box testing. So, this testing becomes a very important component of the entire software development life cycle phase, where we spend almost around 30 to 40% of the time on testing alone, because if at all the system has not undergone on this particular phase of testing, then there is a likely chance that the system may not be reliable for future use. So, this testing is safety critical process, and the cost of testing is several times higher than all the other activities combined. So, the cost of testing element associated is very high when compared to all the design, coding and requirements phase. Many a times we may have to think it from a larger perspective, where the coder by himself will write testing, or but the coder by himself will write test cases and will do a testing, and the person need to have a split personality, where when you start for testing it will be like a paranoid or malicious, where we tend to understand with what as a knowledge, with what as a functionality I have started my coding and where it has gone wrong. At more than certain times the coder by himself or the developer by himself may not be able to understand how it has gone wrong. So, this brings us a surprising difficulty, where they do not point out clearly where they would have gone wrong, or rather the mistakes done by them may not be appropriately possible for them to highlight. Rather, we need a third person who can check on this particular code either, or the functionality of the project, so that the functionality of the software, so that they find the error. So, the objectives that we put forth for this kind of a testing is to find errors, and when we say good testing, we have high probability of finding an undiscovered error, and if at all we say it as successful testing, we discover unknown errors also. So, for doing a component of testing, two things are primarily important, very important. One is called test data and the other one will be a test case. Test data will be inputs which have been devised to test the system, whereas test cases are nothing but inputs to test the system and what are the predictable outputs from these inputs if the system operates according to its specification. So, when you look at test case specifications, it will be input, pre-test state of the software and the possible expected results or an outcome of the software will also be given as a test case. We have looked at two important components, one is good testing and successful testing. What are the likely probability that we make the test to pass? So, if at all the test has to go through a stage to clear itself, then we may have to assure that the software minimally works. We should not push for the capabilities of the software, rather we should make it very simple and straightforward, so that every single test cases flow through this process, and we do not also try to break the program. So, we will not break the code at every different levels and then try understanding how this code really works. Whereas, at an alternate case, we have test which makes a specific software to fail, so that it avoids a later impact. So, we may have to design and run test cases with sole purpose of breaking the software. So, any specific software, if it is found to be failure intensive, then we may have to break the software at appropriate places, so that the operation also tends to break, and that has been made as a subsystem or a module. Then this breaked software is made to execute successfully and it has been combined with the other components. So, strategically chosen test cases to probe for common weaknesses in the software. So, here comes the actual need for this particular session, which is black box testing, where the input to the software will be known and we will also understand on the outcome of the software, but then we will not be actually putting forth what does the system do. So, when we look at the characteristics of black box testing, we have program which are treated as black box, implementation details are not required, does not matter. It purely requires end users perspective alone. What does my customer expect if I am giving this as an input? What does my customer understand if I give my input in this way? There will not be a precise criteria that will be mentioned. There will also be test plans that can begin at the early stages. So, right at the requirement stage, we can start doing this black box testing even. Right at the design phase, we can do this black box testing. It is not required that it has to flow through a continuous process of analysis, design, coding, only then we can do a test. Rather, once we have understood or finalized on our software requirement specification document, after that we can do this test case of black box. So, this black box testing can also be mentioned as specification based testing, because we do a testing once after the requirement specification is done. So, this black box testing refers to a list of test activities using specifications that are based out of testing methods, and we have certain criteria which are to discover program errors based on program requirements and product specifications. So, once after the specification is done, we can write test cases with the help of black box testing or with the help of specification based testing, but then this can in turn direct the coders with appropriate actions, or this can flag the coders with appropriate necessities and necessary actions that they may have to undergo at the time of implementation. So, most of these testing focuses on specification based function errors, specification based component or system behavior errors, specification based performance errors, user oriented usage errors and interface errors. To continue with, testing software against a specification is an external behavior. So, we look for the external behavior of a software without understanding the internal knowledge or the implementation details of the software. So, this can be applied for any software units where classes are being defined, and we understand on the external behavior primarily by looking at the API documents, functional specs, requirement specs, etc. So, the goal of this black box testing is to derive set of input conditions that fully exercise the external functionality as specified in the specification document. So, for this we might have to clearly understand on the information domain, which necessarily takes some input and understands the outcome as expected by the user. So, we value on the input that are given by the individuals. We try many different values for each individual input. Not only that, we go for multiple combinations where individual inputs are not independent from each other. So, they are dependent. Program process multiple input values together, not just one at a time, and we may have to try as many different combinations of input in order to achieve good coverage of input condition. Say for this example, I have indicated you with 3 different testing that is possible. One with best case, and we have a boundary value condition, and we have a worst case. So, boundary value condition is to test on 2 different boundaries, and we have worst cases where we can test it with any different value, and we have one more which is to check appropriately on the limits that is given. To be very safer, we check between the limits, and at extremities what happened when we give the boundary values, and we also check for the worst case values. How does the system behave is the basic testing that we are about to do with the black box testing. So, after this we may also have to order, and we may have to time the inputs that comes in. Basically, I was trying to talk to you about best case, worst case, and a boundary case. So, best case is something that we can check well appropriate numbers which are given, or numbers or any values or any data that is given appropriately within the range, or which gives a positive response for the system, and at the boundaries and worst cases. So, we may have to order it properly, like best, boundary values, and worst cases. And given a various time input, we may also have to look at the various combinations of input values that are being chosen to understand the differences between the various inputs that are provided to the system. Let us try to understand with a simple example where I am trying to give an input domain. For a Boolean value like problem, you may have to rather mention it as either true or false. So, apart from this, we may not have any other constraint to be specified, and if at all it has been a numeric value between the range minus 99 less than or equal to n less than or equal to 99, it can be integer or floating point. So, then every check that we tend to do should be within this range. One of the fixed set of enumerated values, like the months available for a year and different cards that we discover, and we look for the formatted strings like phone numbers, file names. These are unique representations by where we follow a standard templates. So, phone numbers, file names, URLs, credit card numbers, regular expressions are certain things where the user definitions or design model has been performed. So, we maintain a template. According to the template, this has to be functioned. So, through the black box testing, the first ever testing that we are about to do is a equivalence class partitioning, where this will be typically an universe of all possible test cases. In case if it is so large, then you can try all of them. So, you have to select a relatively small number of test cases to actually run. Say for example, having given the number 1 to 99, you need not check for all the numbers starting from 1 to 99. Instead, you can select few values which can give us correct outputs, and which does not, or any numbers which does not impact more on the previous inputs. So, which test case should you choose is the appropriateness measure that we tend to use in equivalence partitioning. So, with equivalence class partitioning, we may have to initially divide the given set of inputs as a valid class and an invalid class. So, partition the test cases into equivalence classes as valid and invalid class. Each equivalence class contains a set of equivalent test case, and 2 test cases are considered to be equivalent if we expect the program to process both in the same way. And if you expect the program to process 2 test cases in the same way, perform test only one of them. Thus, reducing the number of test cases that you may have to run. So, this is the first level of partitioning that you will tend to do. You will divide it into valid and invalid test cases. Within this, we will have appropriate classes, say for example, this belonging to one class, this belonging to other class, these 3 test cases belonging to other class, we may have to divide, and it is more necessary that you test only one value of this appropriate class. It is needless to test for all the values. So, just look at within the valid and invalid classes, we have classified, or we have rather partitioned into equivalence classes. So, these 2 instances make one class, these 3 another class. Likewise, we have partitioned into many classes, and we need not test the basic objective with which we start up equivalence classes. We need not test for all the values in a particular class, rather any appropriate value consider or any value taken from an equivalence class should alone be tested. So, one in every class will be tested for both valid and invalid inputs. So, when defining these test cases, you may use different definitions for equivalence. Let us say if at all we consider an integer type add n1, n2, n3 as numbers, we partition these test cases by the number of inputs like 1, 2, 3, which is replaced by n1, n2, n3. Partitioning test cases by the number of signs they contain, say for example, it can have a positive value, it can have a negative value, or it can have a mix of both. Not only that, partitioning these test cases can be on the magnitude of operands, like there can be larger numbers, because we have not specified on the maximum value of this number. So, there can be larger numbers, there can be smaller numbers, or there can be both associated. So, the one number can be in lakhs, one number can be in 1000, one number in hundreds. Likewise, we can have different possible combinations. So, equivalence partitioning will do an appropriate check on identifying any one value of these classes, and only that particular value will be tested for as a valid or invalid case. Let us look at other example. For fetching a string from an URL, we partition the test case by URL protocol like HTTP, HTTPS, FTP, file, and so. And not only that, we can have an URL of HTML type, another image file format type like GIF, JPG, and plain text format types also. Not only that, URLs can be very short, medium, and very long. So, these are the basic things that we tend to categorize, and we identified what should be tested under each and every category. At least one of the elements should be tested under one of the category. So, this becomes equivalent class 1, in which we test at least for HTTPS, say, and this becomes equivalence class 2, in which we test for at least any file with extensions JPEG, and this will be equivalence class 3, wherein we test for only longer, very long URLs. Likewise, we partition initially into valid and invalid inputs, and then we divide them into classes. Within this class, at least one of the items should be tested. So, we test multiple values in each equivalence class. Often we are not very sure if you have defined equivalence class correctly or completely. So, we may not be certain that we have defined all of them completely. So, in that particular case, testing multiple values in each class is more though than relying on a single value. So, if at all, if it is not very satisfiable to test at least one of its classes, it can extend to one or more. So, it is mandatory that within a specific class we test it for at least one value, and if at all we feel it is incomplete, then we can go for higher values also. So, let us look at this equivalence class partitioning with an example. Having given this input, an integer n between the range -99 to +99, what are the valid equivalence classes and what becomes the invalid equivalence class. Likewise, we will consider another example called fold number, where we mention an area code, we have a prefix, and we have a suffix. So, we can define on this when we code it, but when we this also comes as a specification. Area code is ranging between 200 and 999, and prefix is also ranging between 200 and 999, and suffix is only 4 digits. So, we tend to understand what are the valid equivalence classes that we tend to do initially. So, these are the valid equivalence classes. Say for first input, an integer which ranges between -99 to +99, the valid equivalence classes are -99 or -10, -9 or -1, even it could be 0. So, that is well within the range 1, 9, 10, 99. So, we start out with the values which are from one extreme and we are ending with the value on the other extreme. So, this becomes valid equivalence class, and invalid equivalence class is any number which goes beyond this range, that is -99 less than -99 becomes an invalid equivalence class, and we have any number more than the other boundary also greater than 99. So, these becomes the more of boundary values, and there can be malfunctionality values also. So, supposing that I mention a number which is 12 minus, instead of -12 I mention it as 12 minus, that becomes a malfunction, and I mention a number which is being separated by a hyphen 1, hyphen 2, hyphen 3, which is also a malfunction. Likewise, for non-numeric strings I have a value called junk, I have an exponent, I have dollar symbol associated, and I give an empty value, which are not acceptable. So, these values becomes invalid, and this also needs to be tested. So, when a coder does a job or a developer performs his own operation, it is his responsibility to look at, he writes a program only for correct set of test cases. So, he will completely do on these values, but then it is his responsibility also to look at the invalid cases. If at all he has missed out, the tester takes in the responsibility and fills up this gap by mentioning these are also a possible set of test cases for which the system behaves or responds positively. So, in that particular juncture we may have to take an appropriate action. Likewise, for another input like phone number, the valid equivalence classes are, say for area code we have mentioned it as 555, and for suffix we have mentioned it as 4 5s, wherein we have mentioned any 4 digits, and for area code with prefix and suffix, that is also been mentioned, and these are various formats through which we can mention all of the valid inputs, whereas the same becomes invalid if we do not segregate. So, there seems to be a hyphen which is missing out here, or we put in braces for everything which is not acceptable, or the area code which can be mentioned in this format. So, we are quite dependent on the prefix and suffix that we tend to follow. So, hope the valid and invalid equivalence classes are being correctly distinguished, and by understanding this, within this it is our responsibility that we test for any one of these values, identify say 0 as one of the value and test it, then this should be the same case for all the values. If you feel this 0 is not sufficient for your testing, then that can be performed with any one of the value with the lower range and any one of the value in the higher range. Likewise, we take out from a equivalence class at least one value to test initially, and if this testing does not have performed or a tester feels that this is not complete, then he can go on other values also. So, that was with equivalence class testing, where within the acceptable range we are able to test it. So, that was equivalence class testing, but then at times it is the system has to understand, say at the requirement specification level, the consumer or the customer would have told you that the system has to behave in such a way given this constraint, and the constraint has also been put forth in the coding. But then at certain times there can be an understanding at a different level. When having documented, this is the SRS specification would mention that the boundary values need not be tested. So, we may also appropriately have to check on the boundary values. So, when choosing these values from the equivalence class to test, the values that are most likely to cause the program to failure would be the measure of the boundary values. So, error tend to occur at the boundaries of equivalence class rather than at the center. So, any number which is well within the limits will perform always beautifully when it comes to the real implementation. So, a developer can do his task for any numbers well within the limit, but then his responsibility also lies on to understand the limits further. Say in case of the phone number that we have mentioned earlier, if 200 is less than the area code and area code less than 999, so is it within the valid area? So it is wrong. So if 200 less than or equal to the area code, so any number if I fix it between 200 and 999, I am not considering 200, I am not considering 999, but the intention with which the customer would have given this program to execute should also include 200 and 999. In that particular juncture, boundary values have been missed. So 200 should be considered, should be written like if 200 less than or equal to area code and area code less than or equal to 999. So the testing area codes like 200 and 999 would catch this error, but the center value would execute appropriately well. For the previous program also 770 would execute or give me a positive reply. For that reason I should not test with 770 and say that the system responds fine. So 770 responds fine, but then it is responsibility to check for the lowest of the or the boundary and the next boundary value, and here also it is a responsibility to check for the higher boundary and the previous boundary value. So this boundary value analysis gives an addition to the test center values where we should test the boundaries right on a boundary, very close to the boundary on either sides. So that means 200 and 201, and at the another extreme 999 and 998. So with the previous equivalence class we have distinguished clearly as valid and invalid classes, and within this valid class I have few of a certain instances which are within the limits, but then I have some boundary values which are also supposed to be tested. So these are supposed to have, so for equivalence class I would have taken one instance from every equivalence class and I would have tested, but then it is our responsibility to test for the boundary values, one in the predecessor and one which follows immediately. So these three values combine to test and project me with the value of boundary analysis. So what should be for the example that we have already provided with, what should be the test case or boundary case that we may have to write for the input minus 99 less than or equal to n less than 99. So we may have to test for minus 100, minus 99 and minus 98, which becomes one boundary condition. The other boundary condition would be minus 10 and minus 9, which are well within the limits. The other boundary condition would be minus 1, 0, 1, which will be at the very good levels, and the other condition would be 9 and 10 and 90, 98, 99 and 100. If you look at all the 5 test cases, these 3 test cases are pretty well within the limit, but then how does it perform when it comes to the same number that we have been mentioning earlier. But these are the exact boundary cases that we may wish to perform, say minus 100, minus 99, minus 98. If the system says minus 100 is well within the limit, then we may have to actually look at the coding and correct ourselves. Likewise, similar activity is being carried out for the phone number also, where the appropriate boundaries need to be checked, say for area code 199, 200 and 201. So having given the limit 200, one number below and one number more than that has also been checked. In short, in this particular session we have started discussing about black box testing. The intention of the black box test has started just after its specification. So we can call this as specification based testing. By just understanding on the function of the software, we can start with the testing. So this comes with an approach, or rather a simple set of questionnaire like why should a tester always start with test to passed approach. So any specific tester will make the system to pass primarily having an objective of minimum condition having met. So it is not this a waste of time, that is another preliminary question that we may also have to answer, and what are the various occurrences for it to pass, that is made clear for us to understand. So should not the programmers do test to fail also, is a basic intention that we are trying to clear it during the discussions that we are having on black box testing. Thank you.